In this video, we're going to learn about gas pressure. Pressure can be defined as the force exerted by a substance per unit of area on another substance. So you can think of it as when you walk down the sidewalk, every time you take a step, your shoe is going to exert pressure on the sidewalk. And the area that your shoe exerts the pressure on is going to be equal to the area of the bottom of your shoe. So it's confined to that space. Now we usually measure the pressure in units of newtons per meter squared, and the unit newton is going to be a unit of force, and then meter squared is a unit of area. Now gas pressure can be thought of the force of the gas particles as they collide with the walls of a container with a gas inside of it. So when you blow up a balloon, the reason the balloon holds its shape is that the pressure inside the balloon is greater than the pressure outside of the balloon. Now there's gas pressure all around us. We don't notice it because we're used to it, but there are billions and billions of gas particles colliding with us all the time. These particles are also colliding with the outside of the balloon. You can see the purple particles here representing the external pressure, or the pressure just of the atmosphere. Now those particles are colliding with the balloon trying to deflate it, but the particles on the inside of the balloon, that's these yellow ones here, are colliding with greater frequency because there's a lot of particles confined to a small area, and so the balloon is able to hold its shape. Now we measure pressure, gas pressure, in units of pascals. And on the Earth at sea level, there would be about 101,000 pascals. So pascals are actually a really small unit compared to the standard atmospheric pressure, or in other words, the pressure of all this atmosphere above us. So since pascals are so small, we usually use kilo-pascals instead. And we use the symbol kPa to describe kilopascals. All we have to do is divide this number by 1,000 and we'll get the standard atmospheric pressure in kilopascals. And so this is usually shown in textbooks as 101.3 kPa. Now there's other units of pressure as well that we measure standard air pressure, and one of the most common units is called atmospheres, and we abbreviate that ATM. Now atmospheres are a really nice unit because at sea level, the standard atmospheric pressure in atmospheres is going to be 1 atmosphere because there's literally one whole atmosphere above you, so it works really nice. There's one other unit that we use a lot to measure air pressure, and that's called millimeters of mercury. Millimeters of mercury is based on a device called a barometer. And a barometer is a device that measures air pressure. Now, the old style of barometer consisted of a tube that was filled up with mercury. That's what this tube represents right here. And the bottom of the tube would have been open and submerged in this big container of more mercury. Now, the mercury stays inside the tube, just like when you would put your finger on top of a straw, put it into your drink, and then the drink would stay inside the straw until you released your finger from the top. So as the air pressure increases in the atmosphere, there would be more force pushing down on the mercury in this container, and that would cause the mercury to rise up higher in this tube. Now at standard pressure, when scientists measured this, when they first created it, measured the amount of mercury inside this tube, they found that it was 760 millimeters of mercury. And so this is our other unit that we use. This is standard pressure in millimeters of mercury. We also use the torr, and millimeters of mercury and torr are going to be the exact same thing, 760. So how do we convert between these units? How do they all relate to one another? Well, 1 atmosphere is going to be the same thing, or in other words, equal to 101.3 kilopascals, which is going to be the same thing, or in other words, equal to 760 millimeters of mercury. Now we can use this relationship right here as a conversion factor. We can create conversions to be able to solve problems. So let's take this over here and use this to solve this problem right here. So this question is asking us to convert 45.6 kilopascals into units of atmospheres, and then to convert that also into units of millimeters of mercury. We're going to use this little relationship that we created to solve this problem. when I like to read a problem, a word type problem in science, I like to underline some of the information here. I like to underline the given information in green. This is just to help keep organized. And then underline the information that the question's asking for in red. So we're converting to atmospheres and millimeters of mercury. So this is what I know. When I solve a conversion problem, I always like to solve it the same way. I first start by just writing down the given information with the appropriate unit. So here's the information I'm given in the problem. And what I'm going to do is I'm going to multiply this number by a conversion factor. And a conversion factor is just a fraction that has the new unit that we want to end up with. We're going to put that on the top. And it has the old unit that we want to get rid of. In this case, we're trying to get rid of kPa, and we're being left with atmospheres. When we do it like this with a conversion factor, if you see the same unit on top and bottom like this, we can cross them off, and we'll be left with units of atmospheres. All we have to do now is look at our relationship up here and take these numbers that correspond to these units and just plug them into our conversion factor. So you can see I literally just took those numbers out of that relationship, plugged them in, and now I'm going to do the math. I just take 45.1 and I multiply that by 1 over 101.3. In other words, I take 45.6 and I'm going to divide it by 101.3, and I'm going to get an answer of 0.459 atmospheres. And so there's the answer to the first part of the question. Second part of the question, I'm just going to take that original number again, and this time I'm going to convert it into millimeters of mercury. I'm going to do the same thing where I'm going to make a conversion factor. The new unit I want is millimeters of mercury. I'm going to put that on the top. The unit I want to get rid of is kPa. I'm going to put that on the bottom. And then once again, I'm going to look at my relationship, and I'm going to take those numbers out, plug them in. So 760 millimeters of mercury is the same thing as 101.3 kilopascals. When you plug this in on your calculator, you can take the original number, 45.6. You'll multiply that by 760. You'll get an answer. You'll divide that answer by 101.3, and you should end up with 349 millimeters of mercury. And so that is gas pressure, and those are three of the most common units we use in gas pressure and how to convert between those units.